And we're going to do 11.8, and it's called Power Series, Part B. And we are going to be asked to do the same kind of questions. We're going to find what's called the radius of convergence. It's typically given the letter capital R. And we're going to find what's called the interval of convergence. So exactly the same as before. So what's the difference? The difference is here. We are going to find the interval and radius of convergence of a power series where it's no longer x to the n, or x to the 2n, or x to the n plus 1. It's going to be an x minus 2 to the n and x plus 3. In other words, this guy isn't x anymore. Okay, that's the major difference. If you want to know the jargon, because you might see it somewhere, we say that this is a power series centered at a equals 2. The normal power series, which is actually much more typical, is the one that just has x to the n. And they probably won't call it this, but if they did want to call it that, they could have said it was a power series centered at a equals 0. But we just call it a power series when it's x, so we don't have this bit. So we only use this definition when it's not centered at 0. And I think the good news here is that to find the radius and interval, we're going to do the same stuff. We are going to use the ratio test, typically, and maybe, pretty rarely, maybe the in-through test. So remind you how that one goes. We find that guy, right? It's a little bit messier, but only a little bit. It's at the end that the major difference happens. So it's going to be the limit as n tends to infinity. En plus 1 is all of this, but with n plus 1. So what that's going to look like? It's going to look like x minus 2 to the n plus 1. That n squared is going to be called n plus 1 squared add 1. Then an on the bottom basically is this guy, but we turn it upside down, it saves us a line of working. So I'm going to call it n squared plus 1 over x minus 2 to the n. Are you comfortable about where all those pieces are coming from? Okay, so now we'll move on. Remember to keep the absolute values in these questions. You never lose them. Right. There's not an awful lot going on here, but whatever is going on, you should do it. Can you see any kind of cancelling here? Something in the top killing off something in the bottom and something left behind.
Well, if you factor out an x minus 2, you can then say that x minus 2 to the n and x, minus 2 to the n cancel.
So on the top or the bottom, what happens to the x minus 2 that's left over? Top or bottom?
Well, it's on the top.
Right, that's it. Now, n squared plus 1, I'm just putting a little bracket around it because I want to. And this guy in the bottom, I'm going to FOIL it out and put a little bracket around it. So it looks like that now. So far, so good. Now, typically, what we're going to do next, and I'm putting this extra line in, I'm just going to pull that x minus 2 out of the question, right? So it's out the road.
Didn't we forget a +1?
Shouldn't it
It's
be a
n plus
plus 2?
1 squared +1, right?
Yeah. And then you add another 1 to it. So that should be n squared plus 2. See, n plus 1 squared had n squared plus 2n squared plus 1, but another 1 makes it 2. So I missed a 2 there. Is that okay? Right. Okay. What's n squared plus 1 over n squared plus 2n plus 2 going to get you when n goes infinite? Going to get you 1, isn't it? Can we skip the line? Because I'm not doing it, but you should. Well, you should at least in the test. Isn't that L'Hopital will do that for you, or divide Tottenbaum by n squared will do it for you. But whatever way you do it, you get 1. So 1 times x minus 2, we now have that guy. Are we good so far? That the ratio has generated this limit. Now, the ratio test says that you converge when the answer to the limit is less than 1. Agreed? And so we now have half our answer. Isn't the radius of conversion which we call capital R, isn't it 1? Okay. Now, interval of convergence. That's the bit that's a little bit trickier. I think up to now it's been pretty much the same sort of a map. Nothing too different has happened. But now we have to find out what range of values does that correspond to. So now we're going to have to bring back something from Math 141. If the absolute value of x minus 2 is less than 1, that is the same as that. Does that ring some bells? If I do it as a simpler version, if I said to the absolute value of x was less than 2, wouldn't that make x between 2 and negative 2? Does it ring some bells now? If not, well, you just remember that this always becomes that. So if this was x minus 2 less than 50, minus 50 and plus 50 would be the boundaries. Now, we're not finished yet because I want to know what x is between. Well, what would I do to find out what x is sandwiched between? Agreed. I saw your lips move, Molly. Add 2. Do you notice that the interval of convergence is not symmetric? You remember when we did it with just the x's, wasn't it minus 2 to 2, minus a third to a third, right? It was always plus and minus the same number. Do you see how the interval of convergence has now changed? Right now, the interval of convergence is that guy. But don't we have to test the 2 endpoints?
Can I ask a stupid question?
Go for it. It's not stupid
All right.
questions, they're only stupid answers, and that's my problem. Right, go for it.
I was trying to explain what I wanted to do on my test. I got to this point and I was like, now we have to solve the endpoints to see if we use round brackets or square brackets.
Correct.
What's the right way to say that? Is it closed endpoint brackets versus open endpoint?
Closed. Open.
So that would have been the right nomenclature?
Yes. Closed means you use it. Open means you don't use it. Right now, these are open until I find otherwise, right? So right now I'm saying only numbers between -1 and 3, but not using, that's not very curved looking, is it? Yeah. So let's do the test. We call these numbers the end points. So the first one I'm going to test is that one. And the other point I'm going to test is that point. And if it converges, if the series, i.e. this power series, converges with these x values, then we use that point, and if it diverges, we don't. So let's take x equals 1 first, -1 I should say.
Where'd
If
you
you-
get the negative?
I have no
If you
idea.
add,
I
okay,
have no idea. Don't know. Y'all catch that deliberate mistake, which is normally what I say when I screw up like that. Okay, that's what the guy looks like. If you plug -1 in here, let's see what we get. Isn't -1 take away 2 -3? So you get -3 to the n over n squared plus 1.
You're still doing it with the
I did it again, didn't I? I don't know what's in my brain today. Is -1 to the n over n squared plus 1? Does that converge or not? You don't need to prove it to me, but just looking at it, can you tell if it's going to converge or not?
Yes.
Now, we're not going to do it for time purposes, and you probably won't do it in your homework, but will you do it in a test? How would you prove that, and it does, converge? What test would you use?
P-series.
What kind?
Wouldn't it be, I mean, it's going to go between -1 and 1, and it's going to be a P-series. So you could,
Oh, God, yes, you could do it that way, Tim, but that would take too long. I'm not saying it would be wrong. If you did in a test, you get the points. There are a quicker test than that.
Alternating series.
Alternating series. Yeah, I mean, what you said would have worked, Tim, but this would be much quicker. Right, so alternating series test. Now, I'll try this one, although I'll probably screw up as well. If you plug 3 in here, you get 1 to the n, but isn't 1 to the n just 1? Right, 1 to the power of n is just 1. Right, that guy also converges. And that one isn't going to be an alternating series. But what method would you use to prove that that one converges? P-series now, agreed? You could do a comparison test to a P-series. So comparison test to a P-series. Now, in this particular case, didn't both these guys give me converging series? So the interval of convergence is 1 to 3. And you notice we're doing square brackets to indicate you can use the endpoints. Are we good with this process? It's quite long. And in fact, if you had to do these two from scratch, which you would do in a test, it would be even longer. But if you don't do it in the homework, that's fine. As long as you know what the answer is. Next fella, version question 2. This one's got a little kink in the tail as well. Do you see this power series starts at n equals 2? Did you notice that? In fact, don't power series start at n equals 0 and n equals 1? They're the most common start values. And then sometimes 2 and 3 and 4, but they're pretty rare. Why did this one start at 2 and not at 1?
Because if it started at 1, and we take the natural log of 1 on the bottom, which would be 0, and that'd be a divide by 0.
Right. So that's
is
only,
bad.
which is bad news. That's it. That's the only reason. Do you know you could have started this power series at 10 for who knows why, but you could. And the good news is it has no effect whatsoever in finding interval and radius of convergence. So you can basically not pay much attention to them, which is good, right? Because that one less thing to worry about. If it worked for n equals 2 to infinity, won't it work from 20 to infinity? It's going to work in all those cases. So it's going to be the limit as n tends to infinity using the ratio test again. And it's going to be the limit as n tends to infinity of make all these guys n plus 1. So let's see what we get. An x plus 5 to the n plus 1 a 5 to the n plus 1 and a log of n plus 1. And then turn them upside down, you get 5, a log n, and then x plus 5 to the n. Now I'm going to add an extra line here, which you might not need, but I'm going to do something very specific. You see, all I've done is rearrange the top line and the bottom line so guys match. Not necessary, but I think for this question it might help. Okay, let the battle commence. Tell me some cancelling. Somebody in the top cancelling out somebody in the bottom, and what's left?
All right, the 5n in the top will cancel out the, or we'll cancel out the 5 to the n plus 1. We'll just cancel out the n plus 1. And then on the, also on the top, you can factor out an x plus 5. And then you can cancel.
You're right what you said, but there's a 5 left over, top or bottom?
Oh, the 5 will be left over on the bottom, and
Okay.
on the x plus 5 will be left over on the top.
Agreed. We all happy with that?
I find it a lot easier personally to write it out as like x plus 5 times x plus 5 to the n, and that gets
And then
rid of x
cancel
plus
them out?
1. Yeah, it just works my brain better.
Do it. Always figure out what seems reasonable or obvious that makes you think better. Yeah.
And then you could write those natural logs as subtraction if you wanted.
Oh, not, unfortunately not this time. The log of n, take away the log of n plus 1, does give you a fraction, but it gives you a fraction inside a single log. But two separate logs can't be simplified. So we have some bits and pieces left over here. We've got these two which don't have any n's in them, so I can forget about them for a minute. We are left with this log n over log n plus 1. And I need to know what's going to happen when n goes to infinity. Does anybody know what that becomes? What's the log of n over the log of n plus 1?
Is it 1?
It is. Now, how would we prove it? Because I'm actually going to prove this one, rather than just say it's 1 and move on. What method would you use to prove that this is 1?
I'd use brute force.
If you try brute force, you'd get log of infinity over log of infinity. And that's kind of bad news, isn't it?
Oh, that's right. Okay.
But the answer is 1. So what other techniques have we got? When brute force doesn't work, who's your backup plan?
Can you divide the numerator and denominator by the natural log of n?
That would just transfer the problem to the bottom and we'd be no better off. But I like your thinking.
Do LOHAP.
Yeah, do that, guy. So, forget this. Can I just stick this at the side as that, right? Because it's done, right? And let's do L'Hopital on that. Well, if you differentiate the top, you get this. And if you differentiate the bottom, you get this. Right? But doesn't that become eventually that? And can't you do L'Hopital one more time? And there's your 1. Are you comfortable that that's what L'Hopital would give me eventually? You do it once to get rid of the logs, and then you do it a second time to get rid of the ends. And what you're left with is 1 over 1, and we are good. So that means that we are left with this as the answer to the limit. And according to the ratio test, this should be less than 1. And now I'm going to multiply both sides by 5. And the reason that I'm doing that, because you could say, well, you could just leave it like that. The reason I'm doing this is so that we can find the radius of convergence. The radius of convergence wants x plus 1, x minus 1, or just x on its own, less than a number, right? That's the form that it takes. So now that I've written it like that, are we happy that the radius of convergence is 5? Are you comfortable where it came from? So far, so good? Right, now, let's find the interval of convergence. Well, we take this guy in the center, and it's going to be sandwiched between 5 and -5. And then I'm going to subtract 5 from everybody. So I get a 0 here, and I get a -10 there. So my interval of convergence is -10 to 0.
How'd you get that -10 again?
-5, subtract 5 more. Subtract 5 from all the pieces.
Got
And
it.
this becomes -10.
Yep.
Now, what we would need to do to finish this is, shouldn't we be testing x is -10 and x equals 0, right? Wouldn't that be the two guys that we would be testing to see what happens? Now, I'm going to just cut a lot of corners here. If you plug in -10, you get -5 to the n, 5 to the n, log n. And if you plug in 0, you get 5 to the n on the top and this guy on the bottom. This one simplifies down to 1 over log n. And this one eventually simplifies to -1 over the n over log n. You just trust me on that, you can check it in detail. But when you plug x equals 10 in, this is what the series ends up looking like. And if you plug x equals 0, this is what the series looks like. Let's look at this one. 1 over log n. Is that going to converge or diverge? 1 over log n. Converge or diverge?
Well, that's definitely going to converge because you're going to have 1 over infinity.
Ah, but that doesn't guarantee it, because isn't 1 over n going to give you 1 over infinity, and that one diverges? So it doesn't guarantee it. Any gut feeling about 1 over log n before I tell you then?
I think it
Diverges. Keep going.
diverges. I'm just trying
Ah.
to think this through. I believe by the direct comparison test, because I believe that 1 over log n is always going to be larger than 1 over n.
Correct. That's
Okay.
how you would do it. So this is going to, this one here diverges by a direct comparison test to 1 over n. What about the top one? Be careful. -1 over n over log n. Because Tim was saying something at the beginning there that actually works for this one. Does -1 over n over log n, does that one converge? It does. And isn't it an alternating series test with the guy in the bottom going 0? So what does that give me? It gives me 1 converge and 1 diverge. So on this side, you can use me. And on that side, you can. Okay. So there is a lot of meat on one of these questions, isn't there? There's a lot of stuff you need to do. It's not a very efficient, quick process. It's not. That's just not what it is. Okay, who we got? There only, well, there are 5 questions, right? So in that sense, there's only a few to do, but would you agree each one of them takes a long time, right? So you've got to balance that. What have we got time for? I've got 2 ugly ones, but I only want time for 1 ugly one. Okay, let's do 4. Sigma n equals 1 to infinity, n, b to the power of n, x minus a to the n, And we are being told that A and B are fixed values, right? So what they've done here is basically removed every number in the universe. So there's nothing here. But I want you to treat A and B as constants, right? A is 4 and B is 22, right? That kind of thing. If we do the limit as n tends to infinity then of an plus 1 over an, we get the limit as n tends to infinity of an n plus 1 an x minus a to the n plus 1 over a b to the n plus 1, and then turn everybody upside down with n's. So far, so good. Okay, time to start cancelling. Somebody in the top killing off somebody in the bottom, and something left over when you do that. Who can cancel with who?
B to the n plus 1 and B to the n. You're left with B on the bottom.
Agreed?
A or x minus a to the n plus 1 and x minus a to the n. You'll be left with x minus a on the top.
And for the time being, let's just leave those two guys alone, right? Okay, these don't have n's in them, so they're basically just numbers now, right? So we can ignore them for a minute. What would n plus 1 over n get you? What would the limit of n plus 1 over n be?
1.
1. Couldn't you do that L'Hopital or divide top and bottom? So we are left with x minus a over b. And it should be less than 1, which means that this guy should be less than b. And they told us in the notes or in the question that b is positive, so that is allowed. So we now know the radius of convergence is b. Now, the interval of convergence is that. Are you happy about how this absolute value became this fella, the sandwich as I call it? Right? B and negative of b. What will I do to find out what x is sandwiched between?
Add an A.
Okay, so on this side, I'll call it a plus b, and this side, I'll call it a take away b. Do you see that this is basically showing you a general version of a whole family of power series? Now, we would, and we don't have time, but you are going to test the two endpoints. And if it works, then you'll use it. And if it doesn't, it won't. So right now, the interval of convergence is a minus b to a plus b. But we might get one or both or none of these usable, in which case these would turn into square brackets included. Are we good on that guy? You finish it in your own time? No. And there is one last question that I'm just going to show you and talk about it, but not do it. Hopefully you're looking at question 5 here, are you? No? I can't tell. No?
We are. It's
You
good.
are. Always good. Okay. You see this funny power series? What makes us even different from any of the others? Do you see that little 5x there? Isn't that going to screw up the process? Because it should be x plus 1 or x minus a half. It shouldn't be 5x at all. So if you want to make this thing work, I want you to take this expression here, the 5x minus 1 to the n, and suck it out as 5 brackets x minus a fifth bracket to the n. And that becomes 5 to the n x minus a fifth to the n. So imagine doing that. I'll now show you what I mean. Yes, you might be a visual learner. That guy is not very helpful to do this process on. So I'm saying, rewrite it like that guy. Are you okay with pulling out the 5 as a weird common factor? Now, you can then split it so it now looks like that. And that's the version you should use in question 5 to find limits and then intervals in radius and convergence. Are we good? Excellent. Let's move on to our next section, or at least the notes for it. We're going to be looking at power series as functions. Let me show you a function that has a power series. 1 over 1 minus x. We agree that's a rational function. I'll call it f of x. It's a fraction function. So far, so good. Now I'm going to tell you what its power series is. Wow. That's a very simple power series, isn't it? In fact, if you write it in sigma notation, n equals 0 to infinity, it's that guy. And it's called the geometric power series. Why do you think it's called the geometric power series? Because obviously it's a function that doesn't look anything geometric about it. Why is it called the geometric power series? When I told you about geometric series, weren't they things like 2 to the power of n and 3/4 to the power of n, right? The basic, very simple ones at least were. That's what this guy is. Now, if you have a power series, as we do, are you convinced that 1 over 1 minus x is this infinite polynomial? Because you should be quite skeptical. Right? Okay, let's call it y. So here's a proof for you. Y is equal to, allegedly, 1 plus x squared plus x cubed plus x to the 4 for eternity. Agreed? Now, if I multiply y with x, I get x plus x squared plus x cubed plus x to the 4, because x times 1 gets you x times x gets you x squared, x times x squared gets you x cubed. Would you agree that that is also true then? If y is this, isn't x times y this? Now, what would happen if you took the top one and you subtracted the bottom one? What happened if you took this infinite polynomial and subtracted this infinite polynomial? What would you get left? 1. If you pull out y as a common factor, and then you divide, haven't I just proved that this fella is in fact him. Cool. So we are going to write this fella over here because we're going to use this guy a lot. And this guy, I'm going to write it down in his power series form because it's quicker. Right. We are also going to write down this fella. And this one I'm not going to prove directly. But he's equal to that. How could I use this to prove that? Think substitution. What would you replace this negative x by to get plus x? And think of x's as just placeholders. What would I replace the negative x by to get a plus x?
X squared square rooted.
Ooh, that's making life hard. Make something even simpler than that.
Multiplied by -1.
Okay, how about negative x then? Which is multiplying by -1. That's how you would prove it. So you're going to assume that these are true. And we are going to use those guys to find power series of other fractions. So we're really only going to be, for the most part, finding power series of rational functions. So suppose I wanted to find the power series for 1 over 1 take away x squared. You would use the top one. And what you should do is you recognize shape. Now, for some of you, you've got this concept in your head that x somehow is special and you can't do stuff with it that you could do with other situations. X is just a placeholder. By that, I mean, you can replace this x by anything. For instance, couldn't I replace this x with x squared and I'd get this guy? Would you agree? I could replace this x here on my left with x squared, and wouldn't this guy become that guy? Now, if I replace x with x squared, then what does the power series look like? Well, it looks like n equals something in front, but instead of x to the n, x squared. And this becomes n equals 0 to infinity, and you should make it look pretty. And typically making it look pretty means get rid of brackets and things. So this guy is the power series of that. And if you want to see what it looks like, plug in nothing, plug in 1, plug in 2, plug in 3. How about that? The power series made up of even powers of x is the function 1 over 1 minus x squared. How about this function? Since this has got a negative, think of the top function. What should you replace the x with to get a 1 over 1 minus x cubed?
X cubed.
Are we getting a little bit more comfortable that this x is just a placeholder? You can stick anything you like instead of x, right? Now, that fella becomes there. Here's a different problem. This one is not a substitution. I'm not going to take this x here and replace it by anything. I'm definitely not going to replace it by x cubed. That's what x cubed looks like. What I'm going to do this time is I'm going to think of this as x cubed times 1 minus x. And then I'm going to replace the 1 minus x by its power series. And then the last piece of the puzzle. You might like that answer, but we don't consider it style points worthy yet. Is there a way that this x cubed can be brought inside the sigma? This x cubed, what would happen if you brought it inside the sigma? Any ideas? X cubed times this guy, what would it look like as a single
X to
sigma?
the n plus 3.
It would. Can you just think of it as an x cubed times an x to the n? Just like you said?
Yeah, I got to think about things as being factored out of additions in the power.
Well, did that help in the sense that the way you look at these things, did that bringing it in make more sense now?
Yeah, it works for me personally because that's how I learned pre-calc, I guess.
Okay, it works, you use it. So what we're showing you here is, with a bit of manipulation, can't a lot of fractions be written as power series? So technically speaking, aren't all fractions just power series that you just don't know what they are, right? There's lots of fractions in the world. Some we've managed to find power series for. Typically, we can only find power series for very simple fractions, right? We're not going to go crazy and try and find a power series for, you know, some ridiculous x cubed plus 4x plus 5 over x squared minus 42x. We're not going to do that. There is a technique for doing it, but it is, you can imagine, extremely difficult and not very successful sometimes. But we do know that every function can be written as a power series. And in one way of looking at functions, all functions, is that they're just power series. And if you're a power series, then don't you have a radius and interval of convergence? Agreed? And can't you find it, although I'm not going to do it, the way we did questions at the beginning of today? Have you noticed that these ones are the easier ones centered at 0? Makes life a little bit easier because of that. And that is a perfect time for us to finish. So last name, and you're out of here. I'll hang about for questions at the end. We learned some really cool stuff today. Hopefully your brain isn't hurting, but I think it's phenomenal that every function in the universe is just a power series. We just don't know. We just don't know what all of them are, because some of them are just so hard to calculate that we haven't been able to figure out a way of doing it yet. You know, as
I
a
was playing
formula.
around.
Tim?
I was playing around with the one that ends up equaling Euler's number.
It is. What's this power series look like? Is it? I can't say I remember it.
Pretty sure it's x to the or x sub 1 like to the or over x factorial, x sub 1 factorial.
Oh God.
And then there's a plus 1 in there.
Oh yeah. That is ugly sounding. Just the way you said it. Tessa, power series are cool. Come on. Okay, that was a begrudging hand up. Okay. Any questions before we go?
I have a question, but it has nothing to do with what we learned today.
That's fine.
On the exam, number 6, that one stumped me at the very end pretty hard. I was wondering if you could either do the problem or do an example of it.
I could. I'm trying to. Hold on. Have you got it handy? Because it saves me going
Yeah,
to find it.
I do.
Right. What is it? Just give me it as
Uh,
is. I'm going to be
three-
putting the solutions out to these once the test is graded, so you'll be able to see all my working. But let's do it now, so it's not bugging you.
Oh, I didn't know that. Sorry.
That's fine. No,
3 to the power of n, x to the power of n over n.
that one. And I'm assuming it's in a sigma, right?
Yeah,
Um,
and you wanted a power series.
yeah.
I've never.
No, it is
Oh,
a power
oh,
series. I don't
yeah.
think I wanted. I wanted the radius and interval of convergence of that power series, right?
Yep.
Okay. Okay, so we do the limit as n tends to infinity of an plus 1 over an. So that'd be the limit as n tends to infinity of 3 to the n plus 1,
Yep.
x to the n plus 1 over n plus 1, and turn them upside down. So it's kind of similar to today.
Yep.
Let's see where we go next. Well, we've got all these cancelling things, so that cancels with that, and there's a 3 on the top. This
Yep.
cancels with this, and there's an x on the top. And then I'm just going to leave the n and the n plus 1 alone for a minute. Now, since these are considered just constants and I can ignore them for a minute, would you agree that this guy here, oh, and know what you can say, let me show you what I've got. Yeah, okay. So we can cover these guys up. Would you agree the limit of that is 1? You could do
Yes.
L'Hopital. So what you get is that guy, right?
Yeah, that's
Okay.
what got me. So if that's
Mhm.
that greater than 1,
No, it's still to be tested to be less than 1, whatever it is, which means less than the third. And so your radius of convergence is a third, and your interval of convergence, at least it's going to start off as plus or minus a third, but it might finish with one or other of these two guys making it. And I believe the one that makes it is this one. So it's square on this side, but open on the other side.
so that one, I stopped at 3x and I went back numerous times to try. I was like, there's no way it's 3x.
That's okay.
And
You
yeah,
could
I
be
got it.
anything, right? But you okay, you over the hump, you figure out what to do.
Yeah, I did. I got it. Thank you.
Okay, no problem. Okay, David, Tim, I mean, have you got a question? If not, I'm out of here.